Hello friends, welcome back to my YouTube channel. So in this I am starting the structural analysis too. In that we'll see the indeterminacy. And in indeterminacy there are two types of structures. One is a determinate and second is indeterminate structures. So in indeterminate structures again it is classified into two types, that is static indeterminacy and kinematic indeterminacy. So we'll see one by one. So before starting this we'll see some basic structures. In that we'll first see the external support reactions. In that we'll see how many reactions are there and what is the function of that reaction. So if you have any type of support, the body should have any supporting system, and the whatever the support the body is resting on, the which type of support it is, whether it's a fixed or roller or hinged, we'll see the development of reactions. So the external support reaction, in that we'll see first fixed support. So fixed support, the symbol of fixed support is, so example I am taking a beam. So let's assume it's a cantilever beam. I am taking, this is point A and the point B. I am applying the load at any point, call it as W at an angle theta. So what happens when I applied the load, the deflection will come like this. The deflection will come like this. So after applying the load, the point B, it comes here to here. So when it comes to point A, so after applying the load, the point A is in the same position before it was before applying the load. So it does not move. It is at same position. But when it comes to point B, it moves from here to here. So what happens, is there any formation of reaction takes place at point B? No, because of this displacement there is no formation of reaction takes place on point B. So when it comes to point A, here what happens, in horizontal direction there is no any displacement, so it restrains the displacement. It means the formation of horizontal reaction will takes place. So we'll call it as Rx, because it restrains the horizontal displacement. So in vertical direction also there is no movement. In a vertical reaction also there is no movement. So again there will be formation of one more reaction will take place. We will call it as Ry in vertical direction. It restrains the vertical displacement, so that formation of vertical displacement will takes place. So we call it as Ry. So here the point A to here there is no any slope formation will takes place. It means the formation of one more reaction will takes place, that is called movement in anti-clockwise direction, because there is no any slope exist at point A, so that formation of movement will takes place at support A. So how many reaction total? 1, 2, 3. So Rx horizontal force and vertical and one movement, 2 reactions and 1 movement. So total number of reactions is 3, that is Rx, Ry and one movement will takes place. So in equilibrium equation also, summation of all the forces in x direction is equal to 0 and summation of all the forces in y direction is equal to 0 and summation of all the movement equal to 0. There is 3 equilibrium equations. So now we will move to the next, that is hinge support. The symbol of hinge support is, take a beam at point A is hinged. So if you cut the section here, so when you applied the load at an angle theta, so what happens, here the displacement curve comes like this. the point A does not displace horizontally, so that formation of one reaction will take place, that is Rx, and the formation of one more reaction will take place, we call it as Ry. So here at point A it does not displace vertically, it retains the vertical displacement, so that formation of one more reaction takes place, we call it as Ry. Here at point A there is the displacement comes from here. Point A, the slope formation takes place, it does not resist the slope, so that movement will not come at point A, because the slope is coming from point A, it does not resist the slope, so that movement does not exist at point A. So in hinge support there is only two reactions, one is Rx and second one is Ry. So total number of reactions is 2. So in hinge support movement will not come, it does not restrain the slope, so it allows the slope, that's why movement does not exist. So next we will move to roller support, we will see. The symbol of roller support is like this. If I cut the section here, if this is called point A, if I apply the load at any point here at an angle theta, so what happens here, the horizontal displacement, so that formation of horizontal reaction will not take place in case of horizontal, in case of roller support, because horizontally it moves because the support is having the roller. So when it comes to vertical there is no displacement, it restrains the displacement though, so that formation of reaction will take place in vertical direction, we call it as Ry. So when it comes to horizontal, the horizontal movement will take place here, so that the formation of horizontal reaction will not exist in case of roller support, because it does not restrain the horizontal displacement. So at point A is slope is forming, so it does not restrain the slope, it means the moment formation will not take place in case of roller support also. In roller support there is only one reaction developed, so that is Ry. So we'll come to our topic, that is indeterminacy. So what I am explaining here is this is, so it will helpful in our further explanation, so that I have explained here only. We'll see, we'll move our topic, that is indeterminacy. So in indeterminacy there are two types, that is static and kinematic. So before coming to types of indeterminacy, we'll see what is determinate structures. So determinate structures are nothing but the number of unknown reactions equal to the number of available equilibrium equation. It's called determinate structures. So what it means, whenever number of unknown reaction is equal to the number of equilibrium equations, then that structure is called as determinate structures. For example, so in roller support the only one reaction will come, that is vertical reaction Ry, and in the support the two reaction will come, horizontal as well as vertical reaction will come. So total number of unknowns are 1 2 3 3. 1 2 3, there are three numbers of unknowns. Our equilibrium equations for 2D is 3. So summation of fx is equal to 0, summation of fy is equal to 0, summation of moment is equal to 0. So there are equilibrium equations 3. So here what our determinate structure says, whenever number of unknowns is equal to the number of equilibrium equation, then the structure is called determinate structure. So this is the example for our determinate structure. Now we will move the what is indeterminate structures. Indeterminate structures, when the structure has more support or unknown reactions than the equation of equilibrium, then the structure is called indeterminate structures. What it means, when we have the more unknowns than the equilibrium equation, then the structure will call it as indeterminate structure. So we'll see one example. So I have taken one example. I have taken a beam, one end is fixed and another is hinged. At fixed support, the formation of reaction is horizontal reaction and vertical reaction, and one moment will take place. At in support, the horizontal reaction and vertical reaction will take place. The total number of unknowns are 1, 2, 3, 4, 5. So number of reactions are 5. How many numbers of unknowns are here? 1, 2, 3, 4, 5. Total 5. 5 numbers of unknowns are here. So as I told, 2D there are 3 how many equilibrium equations there? 3. That is summation of fx and summation of fy and summation of moment. 3 numbers of equilibrium equations. So our number of reactions or unknowns are 5. Then the number of equilibrium equations. So our indeterminate structure, what it says, whenever number of unknowns are more than the number of equilibrium equation, then the structure is called indeterminate structure. So this is the example for indeterminate structures. So now we'll see the types of indeterminate structures. There are two types, static indeterminacy and kinematic indeterminacy. So now we'll see the static indeterminacy. So static indeterminacy is denoted as ds. What it means we'll see. So degree of static indeterminacy is calculated by subtracting the available equilibrium equations from the total number of unknown forces. Static indeterminacy formula, we have the total number of unknowns minus total number of equilibrium equations. This is the general formula for our static indeterminacy. So now we will see some conditions to check the stability of the structures. When our static indeterminacy is equal to 0, then the structure is called statically determined structures. And when the static indeterminacy is, the value of static indeterminacy is greater than the 0, then the structure is called statically indeterminate structures. So and our ds static indeterminate structure is value is less than the 0, then the structure is called unstable structures. This value comes in negative value. So when our ds is equal to 0, then the structure is called stable or just stable. If ds value is greater than 0, then the structure is called overstable. We'll see by example. Through the examples, we'll come to know what is stable or just stable or unstable structures. We'll see. So we have taken one example here. So I have assumed one beam here having the one end is fixed. At fixed end, the formation of reaction is one is horizontal reaction and vertical reaction, and one moment will takes place. So total number of reactions is 3. So number of unknowns is 3. So our equilibrium equation is 3. Our ds is what is the formula? ds is total number of unknown minus total number equilibrium equations. So substitute this value in this equation. So our ds is total number of unknowns, how much? 3, and number of equilibrium 3. So 3 minus 3, our answer will get 0. So apply this to this condition. We'll check our ds value. When our ds value is equal to 0, then the structure is called statically determined structure or just stable. We'll move the next example. So to second condition, when our static determined structure is greater than 0, we'll see by example. Have taken a beam, one end is roller support and another end is having the fixed support. So at roller support, the formation of vertical reaction will take place. At fixed support, the formation of horizontal reaction, vertical as well as one moment will take place. So here how many numbers of unknowns are there? Total 4 numbers of unknowns. And the number of equilibrium equations is 3. So substitute this value in our static indeterminate formula. So ds is equal to number of unknown minus number of equilibrium equations. So number of unknowns are 4 and equilibrium equation are 3. 4 minus 3 is equal to 1. So whenever, so apply this to this condition. So when ds value is greater than 0, then the structure is called overstable. ds is greater than the structure is called overstable or statically indeterminate structure. So this is the example for that. Next we'll see whenever ds is less than 0. So have taken a beam. One end is roller and another end is as well as roller. So at roller support the formation of vertical reaction will take place. So here total number of unknowns are 2 and our number of equilibrium equations are 3. So substitute this in our general formulas, that is ds is equal to total number of unknown minus number of equilibrium equations. So 2 minus 3, the answer will come out as minus 1. So our answer will come it as in negative. So it is called structure is unstable structure. Whenever ds value is less than the 0, then the structure is called unstable structure. So this is the example for that structure. So I hope you all are understood. So if you like the video, so like it, share it and subscribe for the more videos. Thank you for watching.